Hi, everybody. Can you hear me okay? I'm hoping so. I'm just going to put the link to the questions at the top of the chat. Then you've got some time to download them. Hi, David. Glad you're here. David, just reassure me that you can hear me all right, would you please? Hi, Louis. I'm pleased you got them printed out, David, but can somebody tell me that you can hear me all right? Oh, brilliant. Thanks. Thanks, everybody. All right, so we're going to start at 11:10, as you can see on the screen. Okay, thanks for coming. I hope you've got the questions. They are a mix of grade 7, grade 8, grade 9. Okay, so I hope that you have downloaded the questions. If you want to get ahead of me, then get ahead of me by all means. Okay, and we're going to start at 11:10. In the meantime, hit like a few things. And hit like a few times if you would, please, and send a Snapchat or a message or a WhatsApp or what have you to anybody else who might want to join the live. See if we can get a crowd here by 11:10. Okay. So hit like for me, send a message or two, and we're going to start at 11:10 in 11 minutes. So you've got time to download the questions and make a start. Now, I think, David, if you can't hear me, then there's a problem at your end. Right. Okay. While you're here, while you're waiting, send me, what topics would you like me to be covering in future lives? What topics are you wanting me to cover in the future? Tell me what topics are on your mind. It's very nice for me, this, because nobody can talk except for me. So you can just type in your answers. Oh, very well done. Histograms, we can definitely do histograms. I'll write that one down. Okay, there is a film on the channel on histograms as well. So if you send me a message, R and J, whoever you are, send me a message, and I can send you the link to the histograms film. Okay. I'll put my email in the chat. Okay, for anyone just joining, the questions are pinned at the top of the chat, so you can hit the link and download those questions, and then you can be ready to go at 11:10. If you want to make a start on the questions, please do. If you have any means of telling other people that we're here, anybody else who might want to join us, please do. See if we can get a crowd here for 11:10. Go over arithmetic sequences. Yeah, absolutely. I'll write it down. Send me an email and I can send you a couple of films on arithmetic sequences. And also one of the questions today is on sequences. So that should help you out. Any more topics you want to cover, just let me know in the chat. Okay, we're going to start in 8 minutes. So you've got lots of time to get yourself organized. High mark probability questions. Yeah, that's a very good topic. Again, I've got a film. Send me an email and I'll send you the link, R&A, okay? You mean things like when you end up with a quadratic equation equaling a fraction, I suspect. Right. The high mark 3D Pythagoras 3D trig. I hate to say it. I've got a film. Send me an email and I'll send you the link. Okay. You got a 9. Brilliant. Oh, that's great. I'm pleased about the vectors film. Vectors is a real tricky topic. And with any luck, those of you on the live have found the films on vectors. If you want me to send you the links to the vectors films, send me an email. My email's in the chat and I'll reply with the links to the films. Okay. And I'm kind of hoping that vectors will come up on paper 2 rather than paper 1. So then you've got the couple of weeks between the papers to sort out vectors. But I know you'll want to get it ready for paper 1 as well. Right, we're up to 20. We're going to start in 5 minutes. Make sure you're organized. Hit like a few times for me. I think that kind of helps people realize that there's a live. Send a message to anybody else you know who might want to join. They've got 5 minutes to get themselves sorted. Let me know any other topics that you want some help with. So far I've got histograms, arithmetic sequences, probability, 3D Pythag, 3D trig, and I've written down vectors as well. With any luck, everyone's quiet because you've downloaded the questions and you're making a start on them. I think that circle theorems question, the second one, is particularly vicious, which makes it quite fun. I reckon if you are going for a 7, 8, or 9, these questions are really good for you. Some of you, those of you who are going for a 9, will probably want to be aiming at full marks on these questions, or the vast majority of the marks. Some of you might think, do you know, if I get any part marks, that'll do, because that'll help bump me up to the next grade. So wherever you're coming from, don't get yourself in a panic if you find the questions tricky, because I've taken these questions from the last quarter of several papers, so they're supposed to be tricky. Okay. Aiming for an 8, blimey. Okay, we're going to start in 3 minutes or so. We've got 20 of us online. It's just gone to 19. See if you can find me some more. See if you can find me some more students by spreading the word in the next 2 or 3 minutes. And we're going to start at 11:10. Okay, we're up to 23. We're going to start in a couple of minutes. See if you can. Oh, we're down to 22 again. See and spread the word. If you want to add to the comments, please do. For last minute revision before paper 1. Well, it doesn't sound very helpful, does it, just to say revise? I'll tell you what, I'll have a think about it. I will also be putting a film on the channel about what I call Dara's ticks, which you'll want to look out for. So if I were you, I'd make sure that you are on my newsletter, on my list. If you're not, then send me an email and I'll stick you on there. And then I'll be sending out some ideas as we're near paper 1. Okay. Right, now I'm hoping that I can zoom up. Okay, and in a couple of minutes, we're going to get started with question 1, which is on the screen here. Okay. Now, while I'm doing this, I can't see your comments. So by all means, leave a comment, and between each question, I will have a check of the comments. Okay. Right, okay, we're about to start with question 1 then. It's 11:10. Here we go. So we've got 2 circle theorems to begin with. Now, whenever I have a circle theorems question, I always just start by thinking, right, what circle theorems might be involved in the question? Now, if I look at question 20, I can see I've got a tangent. So that makes me think intersecting chord. So no, it doesn't. That makes me think alternate segment theorem, the surfboard, the windsurfer. And I can also see a cyclic quadrilateral. So that makes me think opposite angles in a cyclic quadrilateral. Add to 180. I can also see an isosceles triangle there. And I've done that thinking before I read the question, because after all, there are only a certain number of circle theorems on the syllabus. Now, it tells me that those are points on the circle, and it tells me that AB equals CB. So that is indeed, could be an isosceles triangle there if I drew an extra line, couldn't it? Angle BCQ Q is X, well, that's marked, and I'm being asked to prove that CDA, this angle here, that's my target angle. I'm being asked to prove that that is 2X. And I'm being asked to give reasons for each stage of my working. Right, well, we said that the intersecting chord theorem might be, no, we didn't. We said the alternate segment theorem might be useful. So I'm going to draw this line here. And now I can kind of use the alternate segment theorem because, yes, the alternate segment theorem, because if my windsurfer is here, looks down at his feet and looks at the opposite corner, I can see that that angle there will be X because of the alternate segment theorem. So the first thing I'm going to do is I'm going to say that CAB equals X, which equals BCQ, and let's explain why by writing alternate segment theorem. Okay, now I'm thinking about that isosceles triangle. You see, if that top angle is X, then this bottom angle here is also X. Okay, so ACB is X, and Y because it equals CAB, and Y because it's an isosceles triangle. Now look at this top angle here. That will be 180 minus the two angles in the triangle I know. So 180 minus 2x. Better say Y. So ABC equals 180 minus 2x. Why is that? 180 degrees in triangle ACB. And now I can use the second circle theorem I identified, which is that opposite angles in a cyclic quadrilateral add to 180. That angle and that angle must be 180, which means that the angle at D, which was my target angle, CDA equals 180 minus 180 minus 2x, which is 180 minus 180 plus 2x. Hence, CDA is 2x. And here I could write opposite angles in a cyclic quadrilateral add to 180. And that is my solution for question 20. Right, I'm just going to come off here and have a look at the chat. Maybe it's got anything that they want to ask. Okay. It is for Edexcel, yeah, Edexcel IGCSE. These are all Edexcel IGCSE questions. But many of these, all the circle theorems, for instance, appear in the other boards as well. Okay, nobody's asked me a question. I'm going to crack on with the second question on the sheet. This one. Now, this one's much more tricky. Well, I think it's more tricky. Again, I'm going to think which circle theorems might apply to this question. Well, I've got a tangent. So I'm thinking alternate segment theorem again, and I'm thinking if my windsurfer was here looking down at their feet, where would they look? Well, if this is the sail, here, I'm going to need another line there. And now they're windsurfing. So I'm going to add a line from C to B. Now, my windsurfer can look at their feet, and then they can look across. Just losing the plot for a moment. They can look across to here. And so they are looking at their feet, looking across the opposite corner of the sail. So that is 73. Okay, now I haven't actually read the question, so that's probably my mistake. But I've already identified that you can use alternate segment theorem, hence I completed that triangle. Also, I can see I've got a cyclic quadrilateral, haven't I? So I might be able to do something with that. Okay, what else can I see? I've got some parallel lines, so that might help me with something in a minute. Okay, let's read the question. They're points on a circle. AB is a tangent. AB is parallel. Okay. Work out the size of angle DCE. DCE, that is my target. Okay. Give a reason for each stage of your working. Right. Well, the first thing I'm thinking is parallel lines. And I'm thinking Z angles or alternate angles, which mean that this whole angle here is 73. So I think I would start by saying DEB equals 73 equals EBA. Alternate angles are equal. Okay, now I've already found this 73 here, so I better write down why that was. BCE equals 73 equals EBA, alternate segment theorem. Okay, I'm still struggling a bit with finding that green angle, but I've got a cyclic quadrilateral here. Okay, and I know that opposite angles in a cyclic quadrilateral are equal, which means that I can find the whole of this angle that I'm shading in black because it's opposite the 73. So now I think I'm going to get it, because DCB equals 180 minus 73. Okay, so what's that? 107. And why is that? Opposite angles in a cyclic quadrilateral are to 180. And now I can get at my target angle, which is DCE. DCE, that will be the whole angle, the 107, minus the 73 I already knew. That is DCB minus ECB. Okay, which would be, what would that be? 34. And there's the solution for my question 19. Okay, please take note, especially if you want to get a high mark on these questions, of giving your reasons. And when you give your reasons, you have to be really full in your reasons. Okay, you don't get the windsurfer analogy. I can help you with that in a moment. Okay, well, any of this maths works for any maths. Okay, it's not just for GCSEs. The maths is true. All right, whenever you do it. Right, I'm going to do the windsurfer analogy, and then I'm going to the next question. So here's a quick description of the windsurfer technique. If it doesn't work for you, send me an email and I'll send you a film. So here is the sea. Okay, here is, they've changed my OneNote, so I don't know how to draw a circle, so I'm just going to, oh, maybe it'll work like that. There's a circle. Okay, so the C is a tangent, right? Now, here is a triangle, and here is my windsurfer. Here he is, he's holding on to the bar. If he looks at his feet at that angle and looks across there, then those two angles are equal because of the alternate segment theorem. Alternatively, the windsurfer could be on this side and could look down at their feet and across there, and those two angles would be equal. That's just the way I use to remember the windsurfer, the alternate segment theorem. Okay, I'm moving on to this triangle problem here now. So I've got a triangle. So I'm thinking, what is this question going to be about? Well, it's not a right angle triangle. So I've discounted SOHCAHTOA, I've discounted Pythagoras, although I could drop a perpendicular perhaps. But I'm thinking this is going to be sine rule, cosine rule, or maybe the sine formula for the area of a triangle. All of those formulas are on the formula sheet, of course. Right, let's read the question. Here is a triangle. The perimeter of the triangle is K. Given that x is y minus 1, oh, wait a minute. Well, I'll just write y minus 1 here then. Find the value of k. Oh, you just mean find the perimeter, don't you? Show you're working clearly. Right, I've got to find the perimeter of this shape. There it is, that's the perimeter. So I've got to walk all the shape, find the total length. Basically, I'm going to have to find out what y is, aren't I? Now, in this question, I can't use sine rule because I haven't got a side I know and the opposite angle I know. So clearly it's going to be a cosine rule question. So I'm going to use the cosine rule, and the cosine rule that's given to you is a squared equals b squared plus c squared minus 2bc cos a. So this is the angle I know. So that's going to be a, and the side opposite that angle is going to be little a. So I'm dealing with those two. B and C can be any way around. So here we go. A squared. Well, that's x squared, but I'm going to call it y minus 1 squared straight away. Equals b squared plus c squared. Well, 5 and y, doesn't matter which way around you put them. 5 squared plus y squared minus 2 times 5 times y times cos the angle, cos of 60. Pause for a moment, have a look at that, and make sure you're happy with where it's come from. Okay, now, well, just a moment. I know cos of 60 is a half, and if you didn't know that, of course, you could just check it on your calculator. So that's going to simplify that. Y minus 1 squared, I'm going to be really careful and write it out like this so that I don't mess it up. 5 squared is 25, y squared is y squared. Now I've got minus 2 times 5 times y times a half. Oh, that's just 5y. Okay, I think I'm looking all right so far. Expand these brackets. Y squared minus y plus 1 equals 25 plus y squared minus 5y. Tidy up the left-hand side. Y squared minus 2y plus 1 equals 25 plus y squared minus 5y. Now, when you're in your exams, if this is something that you're comfortable with, solving that equation, then do it slowly and steadily. Don't miss out any steps, because if you mess it up, then you won't get the marks you deserve. I'm going to subtract y squared from both sides here. Leaves me with minus 2y plus 1 equals 25 minus 5y. I'm going to add 5y to both sides. I really am taking it steady so I don't mess it up. Minus 2y plus 5y is 3y. Plus 1 equals 25. Now it's straightforward. 3y equals 24. Y equals 8. Now I'll just pause for a moment, give you a chance to look at that. Now I know that y is 8. I can continue and finish the question, which is to find the perimeter of the triangle. While you do that, I'm just going to check the comments. Nothing new on the comments, so I hope we're doing okay. Devon, I hope that windsurfer demo helped you. Okay, and I'm going to go back now and finish off this question. So the perimeter will be, here we go, let's have a look at it over here. The perimeter will be 5 plus y, which was 8, plus y minus 1, which was 7. So the perimeter is 20 centimeters. Okay. Now nobody's chatting to me in the comments, so I'm hoping that everybody's happy. And in a minute or two, we're going to do this sequences question. I'll tell you what, I'll leave that. Just go back to the comments in case anybody wants to ask anything. Okay. Right. So everybody seems happy. Okay, I'm going to go back then and have a look at this sequences question. Now, you need to know for a sequences question like this, which appears towards the end of the paper, you need to be clear on a couple of things. Now, you have got the formula for the sum of the first n terms of a sequence on the formula sheet. In that formula, n stands for the number of terms, a is the first letter of the alphabet, so it's the first term in the sequence, and d stands for the difference between the terms. So that's one really useful formula for you to know, and that's on the formula sheet. The other formula, which is really useful to know, is the formula for the nth term. Now, if you're working out the nth term, you start with the first term, and then you'd have to add on a certain number of differences. You'd have to add n minus 1 differences on. Because, for example, if you're looking at this sequence, I don't know, 5, 7, 9, 11, 13, the first term is 5. If you want the fifth term, it's the first term plus 1, 2, 3, 4 differences. So the fifth term is a plus 4 differences, and hence the general formula is a plus n minus 1 differences. And that's going to be really useful here, because the first thing it says is the 10th term of an arithmetic sequence is 66. So I'm straight away writing down the nth term, which is a plus 9 differences equals 66. And now I've dealt with that part of the question. Now the next part of the question tells me that the sum of the first 20 terms is that. So I'm straight away writing down the sum of the first 20 terms. 20 over 2 times by twice the first term plus 19 differences equals 1290. So I've got a formula, I've got an equation from the top line, first piece of information, and an equation from the second piece of information. And now I've got two equations with two unknowns, and I can solve those simultaneously. Let's just look at this red one first. I hope you agree that that's 10 times 2a plus 19d equals 1290. So I'm going to divide both sides by 10 and just say 2a plus 19d equals 129. So that's my red equation. I'll call that equation 2. And here's my first equation. Let's write down that first equation. A plus 9d equals 66. Two equations here, both with a and d, so I can solve them simultaneously to find out a and to find out d. Right, let's double this second one. So I'm going to copy down the first one. 2a plus 19d equals 129. Double the second one. 2a plus 99, 18d equals 166 times 2, 132. Right, I've made the a's the same. Now I'm going to subtract the equations. Minus, minus, minus. 2a minus 2a, forget it. 19d minus 18d, d. 129 minus 132, minus 3. So d is minus 3. Right, I'm going to use the first equation because that looks more straightforward. A plus 9d equals 66. A plus 9 times minus 3 equals 66. A minus 27 equals 66. A equals 66 minus 27, 93. Now I know that A is 93 and that D is minus 3. So I kind of know all about my sequence now. It goes 93, 90, 87, and so on. I'm going to go back to the question. Find the fifth term of S. Okay. Well, the fifth term is going to be the first term plus 4 differences. So that's going to be 93 plus 4 times minus 3, 93 minus 12, 81. That is the fifth term of that sequence. Okay, there is that question solved on the screen. And I'm going to go to the chat. See if anybody's after anything. You absolutely wouldn't lose all of your marks, absolutely not. So let's imagine that I made a mistake in that question and I thought that, I don't know, 129 minus 32 was minus 132 was minus 2. And so I thought D was minus 2. And then I carried on and solved the rest of the question correctly. I'd probably only lose 1 mark. Okay, all right. So you absolutely will be able to come back to the live. In fact, I think you can rewind it during the live, and also you can watch the live because it'll be on the channel under the lives tab. Okay. All right, so that is question 23. Has anyone got anything they want to ask about anything we've done so far? I feel like I'm going quite quickly, but nobody's asked me to slow down, so I'm hoping you're happy. Okay. Right, well, in 20 minutes, we've solved some relatively feisty questions, and we're going to go on now to the sector of a circle question. Okay, which formula, David? The sum of the n terms is sum of the first n terms on the formula sheet, and the formula for the nth term, the first term plus n minus 1 d's. I guess you just need to think about that as common sense, really. If it says the 10th term, you just need to think, oh, okay, that's going to be the first term plus 9 differences. Okay. All right. Now, let's go back to the OneNote and let's have this question. Right. This is a proper grade 9 question. This one, this circle sector question. Okay. So now there are several different ways of solving it. What I'm thinking I'm going to do is I'm going to give you all a couple of minutes because I want you to have had a go at the circle sector question. And if you come unstuck on it, of course, you can definitely have a go at the Venn diagrams question and the straight lines question. So I'm feeling like I'm going to be quiet. I'm going to be quiet for 2 or 3 minutes. I'll answer any questions in the chat, but why not use 2 or 3 minutes to have a go at the remaining 3 questions? All right. So sorry if you're twiddling your thumbs, but that's what I think you should do. No, of course it's not over for you. What sort of grade are you going to get on your GCSE or IGCSE, William, do you think? Question 23, slightly slower. Is that the one I've just done? Well, an 8 will sort you out for A level. Because that's the order that they appeared when I pulled them together this morning, Gorpy, no other reason. Okay. Wait a minute. For the question 21 and the sine and cosine thing, why did you put y equation for an uppercase x? I thought it should be a different number. Let's have a look. Right. You're asking about this question here. No. Okay, I understand what you mean. Now this uppercase x, right? That's the angle there. Okay. So let me get rid of this. Right. The cosine rule, I hope you're okay with the fact I'm using the cosine rule. Now this is the cosine rule as given to you on the formula sheet. A squared equals b squared plus c squared minus 2bc cos a. Now in the cosine rule as given to you on the formula sheet, you've got a triangle, and on the formula sheet, the triangle looks something like this. It's got a capital A there and a little a there, say. Capital B, capital C, little c. Now the capital A denotes the angle opposite side A. Now, looking at the question here, I want to use this angle. So I'm calling that A for the purposes of the formula, capital A, and that is going to therefore be side little a. It doesn't matter which way round this is, so I think I went BC like that. And now I can use the formula here, and I'm going to have a squared, which is x, but you're told that x is y minus 1. So that's why I went y minus 1 squared here. And that angle, cos A, will be 60. Okay, so I hope that makes some sense to you. If it doesn't, send me an email and I'll help you out. Okay, no problem. Okay, William, to go back to you, if you're getting an H, then A-level maths is definitely a go for you. Right. Do you mind explaining question 23 slightly slower? I'm going to have a quick go at that, and then I'm going to carry on with what we're doing. Which one was question 23? Oh, this one. Now, okay, so there are two things you have to be okay with on this question, and they can both kind of be learned, I guess. All right, now. You're told two things about the sequence. This yellow fact here, that tells you that the first term of the sequence plus 9 differences is equal to 66. That's one equation you can get. And then you can get another equation from this. The sum of the first 20 terms is 1290. So the sum of the first 20 terms equals that, and you have got the formula for the sum of the first n terms. So using the formula, that is the sum of the first 20 terms. So I ended up with two equations, a green one and a red one, and I solved them simultaneously to find out A and D, to find out the first term of the sequence and the differences between the sequences. And then I was able to use that knowledge to work out the fifth term. Okay. Right, 2 minutes and we're carrying on. Yeah, I did just do it, William, but I was just explaining it to somebody in the comments who wanted me to go through 23. All right. So I'm going to go on to the circle sector problem in a moment. All right. Okay, right. I'm going to do the circle sector now. Okay, now I think this is quite a tricky question. I'm going to just get that one out of the way. Right. Now, there are different ways of approaching this question, but let's just read it through first. It says that OPQ is a sector of a circle. Yes, it looks like a slice of pizza. Okay, and that OAB is a sector of a circle, and both the circles have the same center, just like it's drawn, really. A is the point on OP, such that OA to AP is 3 to 2. So that means that if that was 3, that would be 2. And similarly, if OB was 3, then BQ would be 2. All right. And then it tells me the angle at the center is 45. So I'm dealing with an eighth of a circle here. The area of the shaded region is 81 over 2 times pi. Work out the perimeter of the shaded region. Okay. Well, you might be feeling a bit in the dark with this question, and who could blame you? So I'm going to start by assuming that this is 2 and that is 3, and I'm going to work out the area of the shaded section here, okay, the shaded region. Now that area is going to be, if I had one circle, that can be the smaller circle. Here's the larger circle. Okay, not very well drawn. Then I'm going to work out the whole of that. And actually, the bit I'm dealing with is an eighth of that. So I'm going to work out the area of the large circle, pi times 5 squared. And I'm going to subtract the area of the smaller circle, pi times 3 squared. And I'm going to divide that by 8. And that is an expression for the area of the shaded region if those dimensions are 3 and 2. And as luck would have it, that equals 2 pi. Okay? So 2 pi. Now, actually, the real life shaded area of the real life the real life shaded area of the real life sector of the circle, here's the real life one, is not 2 pi, is it? It's more than 2 pi. Okay? Here's the real life one. It's bigger. I don't know what its dimensions are. I mean, it might be 30 and 20, mightn't it? Who knows? It's some multiple of the smaller one. So here's the smaller one, and here's the larger one. And these are similar shapes. This area on the left is 2 pi, and the area on the right is 81 over 2 pi. So look at this. I can use scale factors, I'm thinking, because that to that, I could work out the area scale factor. Okay, so I'm going to go from small to large. Now, the areas. The area of the small is 2 pi. The area of the large is 81 over 2 pi. So I can work out the area scale factor. What has the area of the smaller one been multiplied by to get the area of the larger one? We'll do 81 over 2 pi divided by 2 pi, and you'll get a scale factor of 81 over 4. So that's the area scale factor from small to large. If I know the area scale factor, then I can work out the linear scale factor. It's going to be the square root of 81 over 4, which as luck would have it, is 9 over 2. So the linear scale factor is 9 over 2. So now what I'm going to do is I'm going to work out the perimeter of the sector on my small shape and multiply that by 9 over 2 to get the perimeter of the sector on the real life larger shape. Okay. So I'm thinking there might be a question or two, so I'm just going to pause there and have a look. Crikey, I've just stopped sharing, sorry. I'm going to hope it starts sharing again, otherwise that would be a disaster. Right, I'm trying to share again. I'm aware the screen has probably gone black for you now. Oh no, I think we're back in. Okay. So I'm hoping it's sharing now. Okay. You don't understand the division by 8. Now, I know the area for the shaded. I know the area of the shaded sector there is 2 pi, right? But that's not the real life full size diagram, because on the diagram there, I've assumed that the dimensions are 2 and 3 and that the whole radius is 5. Well, that isn't the case. The dimensions are in the ratio 2 to 3. Okay, so there's no way that the full size one has those dimensions. It can't possibly do, because its area is 81 over 2 pi. So that's why I'm using a small version and a large version. Okay, right, I'm going to make my way back. I know what the linear scale factor is going to be now, so I'm going to work out the perimeter of this shaded sector, multiply it by 9 over 2 to get my perimeter of that shaded sector. Okay, so the perimeter of the shaded sector on the left is going to be pi d, that's pi times 10 for the larger one, divided by 8, because I've only got an eighth of the circle, plus 2, plus pi times 6, because the diameter of the smaller circle is 6, over 8, plus another 2. So that's the perimeter of my smaller diagram on the left, the smaller shaded section. And that works out to be 2 pi plus 4. And so if I multiply that by 9 over 2, I will get the perimeter of the shaded region for the larger diagram, which gives me an answer of 9 pi plus 18, and it wanted the answer in terms of pi. Okay. Now that's a really tricky question, that one. It's a question 22. I think there were only 22 questions on that paper, so that is very definitely a grade 9 howler. If you have managed to get some part marks on that, you'll probably be pleased. You would get part marks for that bit. You would get part marks for working out the area scale factor here, square rooting it to get the linear scale factor, and then, of course, using that correctly. You would also get part marks if you worked out the perimeter of that shaded sector. Okay, so there are lots of part marks to be had there, but it's a horrid question. In a moment, I'm going to do the Venn diagram question, but I will try and help you out. Right, so why did we work out 2 pi if the question already said it was 81 over 2 pi? Well, because we were assuming that the dimensions were 2 and 3. Now they're not, they're some multiple of 2 and 3. Okay. The division by 8, that's because it's an eighth of a circle, 45 degrees. But that is a horrid question, so don't beat yourselves up if you're finding that tricky. You can follow it through again, of course, if you'd like to, by rewatching the live. Okay. But don't beat yourselves up about a horrid question. Right, the Venn diagram question with luck will be an easier one for you. And then the straight line question as well will be one that I hope you can approach. But there's an interesting thing on the straight line question, because you need to show that those lines are or aren't perpendicular in the correct way. So I'll go through that in a few minutes. Okay. Right, let's have a look at this Venn diagram question. Here it is. Let's move it out of the way. Right, 120 people who visited a sports centre were asked if they went swimming, played basketball, or used the gym. Look out, some of them might have done none of those things. Right, the answers showed that 28 people went swimming, and here's the rest of the information. Using this information, complete the Venn diagram to show the number of people in each region of the Venn diagram. Okay. Now, if we start at the top, 28 people went swimming, it's very easy to write 28 there. That would not be correct, because some of those 28 people, maybe they also played basketball, so maybe they should be in here. Maybe they also used the gym, or maybe they also played they went swimming, played basketball, and used the gym, in which case they could be there. So don't fill in that 28. Similarly, you're not in a position yet to fill in the 16, nor the 27. So you might think, oh, that's okay, I can fill in these 3 people who went swimming and played basketball. They're going to go there. No, they're not, because some of them might also have used the gym. So you can't use that 3 yet either. Nor can you use the 5, nor can you use the 7. In fact, to start with, the only thing you can fill in is this. 2 people went swimming, played basketball, and used the gym. 2 there. Tick it off. Now work your way up the list. 7 people went swimming and used the gym. So that's 7 people here, right? And you've already got 2 of them who also played basketball. So that must be 5. Tick it off. 5 people played basketball and used the gym. 5 people played basketball and used the gym. 5 people here. So that means that that is a 3. Tick it off. 3 people went swimming and played basketball. Here we go. Well, 2 of those people also went to the gym. And so there's the 3rd one. Tick it off. 27 people used the gym. That means that I need to have 27 people here. Well, I've already accounted for 10 of them, 5, 2, and 3. So there must be 17 who used the gym and didn't do anything else. Tick it off. 16 people played basketball. 16 people in here. I've already got 6 of them. So there must be 10 of them who just played basketball. Tick it off. 28 people went swimming. I've already got 8 of them, so 20 people there. Now it's easy to think you've finished, but should we just check that we have accounted for all the 120 people? If you add up everybody you've done already, you will find that you have 58 people in this Venn diagram. So you have another 62 people to account for. And those are people who must have done none of those 3 things. So you must put that 62 there. One of the people who went swimming is chosen at random. Find the probability that this person also played basketball. So we choose somebody from this 28 people. We say, right, everyone who went swimming, come over here, because we're choosing from those 28. And what is the probability if we choose from those 28 that that person also played basketball? Well, how many of those 28 played basketball? It's these ones, isn't it? Those 3 played basketball. So the probability here is 3 out of 28. And that is the end of question 16. I'm going to have a quick look at the comments, see if anybody wants to ask anything. Okay, people seem happy with that. Okay, now I've got a couple of tips for you on Venn diagram questions. So let me have a quick look at this. So tips for you. Now, if you're okay with those kind of questions, then that's great. But what about if they ask you to shade different regions? So let's just use this as a bit of a practice here. Now, if they ask you to shade region A, sorry, let's choose a region that's actually on there. If they ask you to shade region S, I'm assuming you're happy that that is region S. What about if they ask you to shade region S dash? Do you know what that means? That means everything but S. So it includes those on the outside. It is everything except for S. Okay, well, I'm assuming that you knew that, or you're okay with that. People sometimes remember that by thinking about that dash as being the beginning of the word not, as in not S. What about this one? What about if they say S union B? Well, that is anything in S or in B. Okay. All right, I live on the Welsh borders. So in the United Kingdom, it includes England and Wales. So you shade England and Wales, the United Kingdom Union. So if you can remember that one, then with luck, you should be okay with S intersection B being all of that. Now, where people get into problems is when it's something like this, dash S intersection B. And the way I would think about this one is I would stop thinking about the word intersection for that, and I'd think about the word and. And I know it's and because it's got the same sign in the middle. This means not in S and also in B. So it has to be in B, but also it has to be not in S. And so it would be that. Okay, and lastly, what about one like this? G union S, like that. That is going to be G union S not. So let's do everything in G union S to start with. Here we go. G union S is all of this little lot. But actually, this question is not those. So I'm going to shade the outside and that bit of B as well. And that yellow bit of shading is not G union S. Okay, right. I'm about to go through the final question. Before I do, just let me see if there's anything in the comments. Okay. All right. No, thank you for your comments, but I think that everybody seems to understand that. Mr. Wright's daughter, crikey. That's a bit of a shock. Right, okay. Now I'm going to move on to the last question, and then by the look of it, I'm going shopping. Right, here we go. Where's it gone? Ah, here we are. Right, the last question. Okay. Right. The straight line L1 has this equation, and the straight line L2 passes through these points. Michael says that L1 and L2 are perpendicular. Is Michael correct? Stop and realize that to answer this question correctly, you're going to have to say either yes or no. You must use the word yes or you must use the word no in your answer, because this question is a yes or a no question. You must show clearly how you get your answer. Now, if the lines are perpendicular, you need to think through what that means. That means something about their gradients. It means that one gradient is a negative reciprocal of the other, or that the two gradients multiply to -1. Let's have a look at L1, and let's see if we can work out what its gradient is going to be. To work out the gradient, we really want to write it as a y equals. And there you are. And now I can read off the gradient of L1, which I'll call M1. And the gradient is the coefficient on the x. So the gradient there is -1/2. So I've got the gradient of L1. Now what about L2? Well, I've got 2 points on L2. I've got -1, -7, and 7, 9. I'm writing them one above the other. And now I'm going to work out the change in y over the change in x to give me the gradient of line 2, which I'm going to call M2. So I'm going to go from the -7 to the 9. Well, that's 16. And I'm going to go from the -1 to the 8 to the 7. Well, that's 8. So the gradient of m2 is 2. Now you might think that that's enough. It's not. You have to then say m1 times m2. Do they equal -1? -1/2 times 2 equals -1, tick. Are the lines perpendicular? Yes. The lines are perpendicular because m1 times m2 equals -1. You could probably get away with saying m1 is the negative reciprocal of m2, or m2 is the negative reciprocal of m1. But my strong advice to you is that you include this kind of thing, because then you're showing it beyond doubt. Okay, and that is the last question there for today's live. I'm just going to go to the comments and check you're happy. Okay, right. So S- union B, you'd like me to do, would you? I can do S- union B. I'll go and do that now. Why did you do y over x instead of x over y? Well, because to find the gradient, it's the change in y over the change in x. Okay, it's not the change in x over the change in y, Devon. Okay, right. No, I don't do French revision. Okay, I am going to, where am I going? Oh, S- union B. Right. S- union B. Here we go. Right. Where am I going? Over here. Right. So have a think yourself about S- union B, and then we'll have a look at it. S- union B. Now the union means or. So I'm thinking about S- or in B. So to qualify for this, you can either be in S- or you can be in B. So anybody who's not in S is going to qualify. So all of these lot are qualifying because they are all not up to there. Everybody who's not in S qualifies for this because it's an or. It's like everyone in England qualifies to be in the United Kingdom. Okay. Right, that's not S, but you also can qualify if you're in B. So these people who are in B and these people who are in B, they're also going to qualify. So now, shaded in blue or yellow is the answer to not S union B. Okay, so that makes sense to you. All right, so I'm thinking we are going to end this live now. Thanks very much for coming. If you want to know about future lives, then send me an email and I'll add you on the mailing list. If you want any particular resources on any particular topics, then send me an email and I'll send you some links. And otherwise, I'm just going to say thank you very much for coming. And I'm going to end the live. So you're finding the x value for question 11. What was question 11? Devon, it's a last minute question. Let's have a look. Which one was question 11? Oh, this last one. Well, the last one, I found both the gradients. I needed to show that the lines were perpendicular, right? So all I needed to do was to find the gradient of one line and the gradient of the other, and then show that one was the negative reciprocal of the other. Okay, because that question was just about, are the lines perpendicular? I didn't have to find anything else out. Okay, right. We are stopping now. Thanks for coming. If you want to come to the next one, get yourself on my mailing list, send me an email, and I'll let you know when it is. Okay. Have a good rest of the day.